So in this video, we're going to learn how to multiply and divide rational expressions. So we'll start off with multiplying first. So let's go back to the basics of multiplying fractions. So when you multiply fractions, you don't need a common denominator. You just multiply numerator, denominator. In this case, you get this, and then you could reduce the fraction. In this case, you divide it by 3. Now there's another way to get this number without actually getting this 15 over 24. So if you look at these two fractions, notice how you have a 3 on the top and the 6 in the denominator. Well, when you're multiplying, essentially it looks like this, 4 over 6. In other words, this 3 and the 6, you can actually reduce it as if it was like a fraction. So divide everything by 3, 3 and 6, you end up getting 1 and 2. So what you're left with is 1 times 5, which is 5, over 4 times 2, which is 8. So we don't get this intermediate unreduced. So when it comes to multiplying rational expressions where you have variables and also coefficients, it's the same idea. So let's have a look at the coefficients first. So you have a 3, 10, and 2, and 9. Now first you should ask yourself, can you actually reduce 3 and 2 and 10 and 9? There's no common factor, but you can ask yourself next, can you actually look at the numerator from one fraction and denominator from the other fraction? In this case you can. You can divide both sides, both numbers by 3, you get 1 over 3. Over here, you got 2 and 10, so you can divide both sides by 2, you get 1 and 5. So in other words, you have 1 times 5, which is 5, 1 times 3, which is just 3. So the coefficient is already reduced, 5 over 3. Now we get to deal with the variables and the a's. So in this case, we have 3 a's on top and 2 a's in the denominator. And if you're to reduce, we can actually remove 2 a's from top and bottom, leaving one single a on the numerator. That's why we have a on the top. If you look at the b's here, now we got 2 b's in the denominator, 2 b's on the numerator. You can remove or simplify b squared, 2 b's. In other words, you're left with b on the numerator. That's how you have a and b on the top. So before we actually reduce and the rational expressions, what we should have done is we should have actually dealt with the restrictions first. So if you notice each fraction here, each rational expression, you have 2 variables. You have this denominator, which we do not want, like in the previous video, to not to equal to 0. And also you don't want this fraction here, the denominator, not to equal to 0. So we solve, we divide both sides by 2, and then we take the square root. Divided by 2, which is 0, and then you end up getting 0. In this case here, divided by 9, you get 0 divided by 9, which is 0. Take the square root. So in this case, these are our restrictions before we actually start to simplify. So this should have been done first before I actually start. All right, so now we have a more complicated looking rational expression. We are still multiplying. So let's actually deal with the restrictions first in this case, unlike the first example. Let's actually factor every single thing that we can factor. So over here, we have a quadratic standard form. We're going to find 2 numbers and multiply -6, but add up to 1. I'm not going to go into details about how to factor. You end up getting this. X minus 3, x minus 2 over, in this case, the denominator, you have x, 2 numbers that multiply to -15, but add up to +2. In this case, you get this. We're going to put a multiply, x minus 3. You can't really factor the right-hand side. So this is what we have right now. So let's actually deal with the restrictions first. So in this case, we want to set each denominator to not equal to 0. So I'm just going to do it quickly on the side here, the restrictions. X cannot equal to -5 from the first one, x cannot equal to 3, and x cannot equal to 2. So we're done the restrictions. So now we can start to simplify things right now. So we look at the overall. I don't see any common factors within the rational expression, but we can see things from across. So if you notice here, we have an x minus 2 and x minus 2. So I'm just going to reduce it. It's 1 over 1. You don't really have to write it down because it's not there anymore. You have x minus 3 and x minus 3. And what you're left with is x plus 3 over x plus 5. This here is your simplified rational expression. So in this example, I think you should just pause the video and try it yourself. Okay, so let's actually start to factor wherever we can factor for each piece. Numerator here, we can actually use the difference of squares, x minus 3 over x plus 3, all over here. You got two numbers that multiply to negative 20 but add up to 1. And that'd be x minus 4. We're going to put a multiplication sign. Two numbers that multiply to give you 16 but add up to give you negative 8. So they're the same. And then here, this one here is going to be just a common factor. You can divide everything out by 3, factor out to 3, and you end up getting this. So let's start up with the restrictions first before we start to reduce. In this case, we're going to set this one here, this piece. We can know that x cannot equal to negative 5. This piece here, x cannot equal to 4. This piece here, x cannot equal to negative 3. This is not relevant. There is no x involved here, so we're not going to deal with that. So now we have our restrictions. Now we can start to simplify. So I can see there's nothing here that's within that fraction that can reduce. So let's actually look diagonal-wise. I see an x plus 3 and an x plus 3. What else do I see? I see x minus 4 and an x minus 4. Anything else? So that's all I can sort of reduce. So we're left with x minus 3 on the top. Now we have an x minus 4 right next to it because we're multiplying the r together, all over x plus 5. And over here, and we're just left with a 3. So 3, I'm just going to put it in front of the x plus 5. So now we're going to actually divide. When you divide a rational expression, when you divide a fraction, for example, I'll put on the side here, if I take 3 over 4 divided by 2 over 3, essentially what I'm going to do is we're going to multiply the reciprocal, the divisor, which is 2 over 3, and take the reciprocal, and then we can multiply 9 over 8. So similar to this question here, but before we actually take the reciprocal of this, we're going to have to state the restrictions of the original question. So let's factor every single piece first. So in this case, two numbers that multiply to give you negative 20 but add up to give you negative 1. This is a common factor in this case here. I'll keep the division sign. Numerator, two numbers that multiply to 20 but add up to 9. That gives you 5 and 4 in this case. Two numbers that multiply to give you 36 but add up to give you negative 12 in this case. Now, before we actually do anything, let's actually determine the restrictions first of any denominator. So in this case, I end up getting x cannot equal to 0, x cannot equal to 6. These are the same, so I don't have to write them out 2 times. So these are our restrictions. We're not done with restrictions yet. Why? Because in the next step, when you divide a rational expression, you have to take the reciprocal. So my next step is to maintain the first rational expression here and then multiply. Now we take the reciprocal. In this case, I'm going to put to the square just to simplify that part. And I end up getting this. So now this becomes a multiplication question. Now, before we actually simplify things, we have a brand new denominator. We need to actually address the denominator for this reciprocal. We took the reciprocal. In this case, x cannot equal to, I'll put it up here, x cannot equal to negative 5, and x cannot equal to negative 4. So I'll put a box around here. So we have actually 4 restrictions. 1, 2, 3, and 4. Once we're done with restrictions, then we can start to simplify. In this case here, I have an x plus 4 and an x plus 4. I have an x minus 6, but I have 2 x minus 6's here, so I'm just going to remove one of them. So we're left with just one of them. Anything else? These are not the same, even though they kind of look the same. They're not identical. So at the end, I have x minus 5, x minus 6, all over x bracket x plus 5. This here is my reduced rational expression.